5 for Year 13 Physics, and it's on Faraday's law and the generator. Now, according to Faraday, the size of the induced voltage depends on how quickly or the rate of change of flux. Flux can be changed two ways, by either changing the flux density or the area. So in these two, the area is the same, but this one has only got 2 lines of flux, whereas the other one's got more. Okay, now if you compare these two, the area is different, but the flux density is the same. Okay, now formula for induced voltage, so is the rate of change of flux, and flux, that's a symbol for flux, and rate of change means it's divided by time, and the negative sign is in honor of lengths. Now, flux depends on two things. So because flux is equal to P times A, we can write the same formula as B times A over T, but if something's got n number of turns, then you've got to multiply it by the n. Okay, now what actually can change is if you have a coil that's spinning in a magnetic field, the area of the coil will change in relation to the lines of flux. It could be parallel or at 90 degrees or at some angle between the lines of flux and the area. Okay, now electric generator. The electric generator consists of a coil of wire that's rotating in a magnetic field. The maximum induced voltage occurs when the flux is being cut at maximum rate. Now, this happens when the instantaneous velocity of the coil is perpendicular to the lines of flux, and this is when the plane of the coil is parallel to the flux. So you have your lines of flux going from the north to the south pole, and the plane of the coil is parallel to the lines of flux. However, it's the edge of the coil is moving at right angles to the lines of flux, and that is why you have your maximum voltage induced in that position. And how do you get the size of the maximum voltage? This formula is not on your formula sheet. It depends on B, A, and omega. So that's your flux density, area of the coil, number of turns, and how quickly is it turning. Okay, whereas where omega is 2 pi f, and that's your angular frequency. Okay, so I've just given an example of the generator. So here you've got a generator where the plane of the coil is parallel to the lines of flux, and it's rotating in this way, and we're just looking at that AB of the coil. This time it's perpendicular to the coil, and now it's parallel to the coil, but AB, which was on this side, has come to the other side, so it's kind of flipped over 180 degrees. So I've given some numbers here. So the area of the coil, that's your flux density. So question 1, what is the total flux linking the coil when it is in this position? When it's parallel, it's 0, nothing is linking. What is the total flux linking the coil when it's in position 2? It is a maximum, so it's B times A. So there's your B, there's your A, and you get that much. And the unit for flux is Weber. What is the size of the change of flux when the coil moves from position 1 to position 2? It is this minus 0, and you get 0.015 Weber. Now, if the frequency of rotation is 10 Hertz, what is the period? Period is 1 over 10, it's 0.10 seconds. How long did it take the coil to go from position 1 to position 2? So it will be just a quarter of that. So you get 0.025 seconds. Now, according to Faraday's law, what is the size of the induced voltage? Induced voltage depends on the rate of change of flux. So you divide that by that, and you get 0.60 volts. Now, if the coil has 20 turns, then what's the size of the induced voltage? You got to multiply that by 20. So there's your N. So you get 12 volts. Why is the maximum voltage induced when the plane of the coil is parallel to the lines of flux? This is because the edge of the coil is moving at 90 degrees to the lines of flux, and hence it is cutting or linking the lines of flux at maximum rate.